Hello, Mr. Hine here, and today I'm going to show you how to calculate net force. Net force is the total amount of force that is working on an object. So like we talked about in class, when something's moving, especially here on Earth, there's all sorts of different forces working on it. We have things like gravity, friction, air resistance, the motion of our own body, all affecting one object. So to really get a clear picture of how that object is being affected, we combine those forces together, and that's what we call our net force. It's very simple. All we have to do is either add our forces or subtract them. And we do that by looking at what direction the forces are moving. If they're moving in the same direction, we'll add the forces. If they're moving in opposite directions, then we will subtract the forces. And I included here a couple of examples of what I mean by that. If we look at this first picture, we have a box, and there are two forces, and they're both pointing towards the right side of my screen. We could imagine that this is like a big, heavy box, and two people are trying to pull it. So their forces are working together, and we'll add that up, and it'll basically be like one big force moving towards the right. And that's going to be our net force. We see the same idea down here in this picture. There's two forces. They're on different sides of the box, but they're still pointing in the same direction. We can even ignore the object itself. The object doesn't really matter because we're just concerned about the forces. So if I took that object away and we're just looking at the forces, we see that this force number one, we could say, is moving towards the left of the screen. It points this way. And force number two is also pointing to the left and going that way. So together, they're both moving the same way. We would add them up, and we would see that they're working together as one big force moving towards the left. Let me move my box back in. All right, those are forces moving in the same direction. We can also have forces that are moving in opposite directions. Over here on the right side of the slide, we see a couple examples of that. Here in this first example, we have this force moving to the left, and we have this force moving to the right. Those are pointing in different ways, so we would subtract those forces. They're working against each other. So if one is stronger, then the object will move in that direction. Like if this force was 50 newtons and this force was 20 newtons, it'd be moving in the direction of this force because it's bigger and it's stronger. We see the same thing happening in this example down here. Again, we have two forces, and they are pointing in different directions. This arrow on the top points to the left. This arrow on the bottom points to the right. So we would take whatever these numbers are, subtract them, and that would be my net force. Let's look at some examples of how to do this with the actual math. So here we have an example of a box. The box has two forces acting on it. This first force is pulling the box to the left with 6 newtons of force. This one on the bottom is pushing on the box, and it's pushing to the right, and that's using 3 newtons of force. Here we have two forces working against each other. This force is moving towards the left. This force is moving towards the right. So what do we do when we have forces moving in the opposite directions? We subtract. So all I have to do to find my net force is take 6 minus 3. We're always going to do the bigger number first. And that is equal to 3 newtons. Net force always has a direction that goes with it, and it's always going to be the direction of the bigger force, no matter what. So in this case, my bigger force is 6, and that's moving to the left. It's pointing to the left of my screen. So that means my net force will also be moving left, because the stronger force is always going to win. Let's look at another example. All right, so in this example, we have a chair, and that chair is being pushed by two forces. This force on the top pushes the chair to the right with 25 newtons of force, and this force on the bottom is also pushing to the right with 18.5 newtons of force. So before I go through this, I'd like you to pause the video, try it out for yourself, and think about what you think the net force is. Okay, so hopefully you noticed that the two forces are moving in the same direction. This force points to the right, this force points to the right. That means we're going to add these forces together. So 25 plus 18.5 means that I have a total of 43.5 newtons of force. And though that force is going to be moving to the right, because both my forces in this case are moving to the right. And it's as easy as that. Let's try a few more examples. All right, here we have a book. Two forces are acting on that book. Go ahead, pause the video, try it out for yourself, and then I'll come back with the answer. All right, here we have two forces, and they are pointing in different directions. This force here is pointing up, and this force here is pointing down. That means we're going to subtract these two numbers. So my net force is going to be 5.5 minus 5.5. And that equals 0. So our net force in this case is 0 newtons. 0 newtons means we have a balanced force. And so the book is not going to move. That means we have no direction here. As we can see, the book is just sitting here on the table. Gravity pulls it down, but the table is also pushing up on the book so that it doesn't fall down to the ground. Overall, there's no motion because the book is just going to sit there. Here's another problem. In this case, we have three forces, but it works the exact same way. Any forces that go in the same direction, you should add, and any force that goes in the opposite direction, you should subtract. So go ahead, try out this problem, and then I'll walk you through it. All right, so in this problem, and any sorts of problems where there's three or more forces, I find it's easier to add the ones going in the same direction first, and then subtract what's going in the opposite direction. So in this case, I have two forces going in the same direction. I have this force pointing to the left, and I also have this force pointing to the left. So I'll start by adding those two forces. This force is 60 newtons, and this force is 40. So if I add those together, I have 100 newtons of force moving to the left. But we also have this big force up here pointing to the right. That is in the opposite direction of these two forces, so we're going to subtract. Now remember, you're always going to subtract the bigger number minus the smaller number. So what I'll do here is I'll do 800 newtons. That's the force of the engine. And I'll subtract my combined force here of 100 newtons. And that's going to equal my overall net force, which in this case is 700 newtons. And it's going to be to the right, because overall I have more force here pointing to the right. And it's as easy as that. So in general, when you're looking at these problems, if you see arrows pointing the same way, add them up. If you see arrows pointing in different ways, subtract them, and that's going to be your net force. There's one more thing I'd like to talk about, and that is balanced and unbalanced forces. With our balanced forces, we're going to see a net force of 0, and that's because the balance are kind of equal to each other and canceling each other out. So we saw that in our example with the book. Gravity pulls the book down, but the table pushes the book up, and overall, the book is just sitting there. So with these balanced forces, we're going to see no change in motion. The object will remain in place if it's sitting in one spot. Unbalanced forces, on the other hand, are going to have a net force that is greater than 0. And so anything above 0 is unbalanced because one force is stronger than the other, and these forces will change the object's motion. So all of our other examples besides the book were examples of unbalanced forces because they were greater than 0 and they were causing the object to move. In the case of our plane, the plane's force is stronger than wind and air, so the plane can move forward. In the case of the chair, our two forces are working together, and so the chair moves to the right. And in the case of our box, there's two forces working against each other, but overall, this 6 Newton force is stronger, and so the box is going to move towards the left. So when you're looking for examples of balanced forces or unbalanced forces, you want to think, what's happening to that object's motion? If it's not changing, that means the forces are balanced. If the motion of the object is changing, then you have unbalanced forces. All right, that's it for today. I hope this video helped. If you have any more questions, just let me know. Bye, guys.